Imagine commanding a spacecraft millions of kilometers away to turn around and snap pictures of our very own home planet and its natural satellite. That's exactly what NASA did with the Psyche mission. And this act is more than just a cool photo op. It's a crucial part of making sure our deep space explorers are ready for what's ahead. Launched in October 2023, NASA's Psyche Spacecraft is on an ambitious journey to study an asteroid known as Psyche, a unique world rich in metal. Scientists believe this asteroid might actually be the exposed core of an ancient planetesimal, a building block of planets that lost its outer layers long ago. Psyche is scheduled to arrive and enter orbit around the asteroid in 2029, promising an unprecedented glimpse into planetary cores, something we can't directly observe with Earth or most other distant worlds. Now, here's where it gets particularly interesting. Spacecraft don't just launch and coast silently. Along the way, their teams perform vital tests and calibrations on scientific instruments, ensuring everything works perfectly by the time they reach their target. Earth, conveniently positioned and well understood, becomes a reliable testing ground for these calibrations. This practice is hardly new. Previous missions, like Cassini-Huygens on its way to Saturn, and Voyager 1, during its historic journey out of the solar system, also captured distant images of Earth. Voyager 1's iconic pale blue dot photo famously reminded humanity of its fragile place in the cosmos. Cassini's image of Earth from afar wasn't just a spectacle. It was crafted by stitching together 323 separate images, showcasing the complexity and care that goes into these observations. Fast forward to Psyche. NASA recently instructed the spacecraft to turn its twin cameras back towards Earth to test how they respond to reflected sunlight, similar to what the asteroid will reflect. In late July 2025, Psyche's cameras took these shots with 10-second exposures, even though the spacecraft was nearly 290 million kilometers away from Earth. This is no small feat of engineering and coordination. Psyche's instruments, particularly the multispectral imager, need thorough testing because they will collect data not only about the asteroid's surface geology and composition, but also its topography, the three-dimensional shape of the terrain. To fine-tune this imager, NASA has Psyche observe objects with spectral properties somewhat like the asteroid. Earlier test images of Jupiter and Mars helped calibrate the instruments by comparing what Psyche sees with data from Earth-based telescopes and other spacecraft. Besides the multispectral imager, Psyche carries magnetometers to measure magnetic fields and a gamma-ray and neutron spectrometer to analyze elemental composition below the surface. The combined data from these instruments will help paint a comprehensive picture of Psyche's origin, surface features, and internal structure. In particular, confirming whether Psyche is indeed a remnant planetary core could revolutionize our understanding of how planets, including Earth, formed and evolved. But here's the part most people miss. Psyche isn't just a static chunk of metal. A 2022 study utilizing ALMA, Atacama Large Millimeter Submillimeter Array, data suggested that Psyche's surface is actually diverse and complex, resembling a world shaped by catastrophic collisions. The researchers propose that a thin layer of fine dust, fractured rock, or silicate-rich material might blanket the otherwise metallic surface, a sign that Psyche has undergone significant cosmic impacts over its lifetime. Visualizing this, astronomers from MIT and other institutions created a detailed surface map of Psyche with ALMA data. Yet this remains an indirect view. We'll have to wait until the spacecraft orbits just 75 kilometers from the asteroid to see its surface in stunning detail up close. These recent Earth and Moon images are merely the beginning. Psyche has 4 more years of cruising before arrival, during which it will continue to photograph other solar system bodies to further optimize its instruments. NASA plans to capture images of Saturn or the asteroid Vesta next, metaphorically collecting solar system trading cards to keep checking that Psyche's instruments return accurate data. The spacecraft isn't just about cameras. Every 6 months, It runs essential tests on its magnetometer and gamma ray and neutron spectrometer to ensure they remain fully operational. Even if these instruments don't produce pictures we can admire, we're in good shape. Everything is functioning well, confirmed Bob Nace, project manager at NASA's Jet Propulsion Laboratory. We're on track to fly by Mars in May 2026, meeting all our planned cruise milestones. So, here's a question worth debating. Given Psyche's unique opportunity to explore what could be a planetary core, do you think missions like this should prioritize in-depth remote sensing with lossy calibration steps? Or should we push for more direct sampling, perhaps bringing asteroid material back to Earth? How do you weigh the costs and benefits of these approaches, especially with a budget and timeline in mind? Share your thoughts, because this conversation has major implications for the future of space exploration.